So in this video we want to verify that basically sine and cos are periodic functions with a period of 2 pi. And the way to verify that, you can basically if you had a coordinate system like this, let me see, for example, you have a coordinate system like this, and I don't know why it's been okay now. So let's say, I don't know if, I kind of have the feeling that this line is not straight, but whatever. So if you have a function theta, for example, let's say this is your function theta. I'm sorry, an angle theta. If you have an angle theta like this, then I forgot what we wanted to do. Right, a periodic function. So if you have an angle theta like this, and then basically you add 2 pi to this angle, so you have theta here, then what is 2 pi plus theta? You basically start from here, you go all around this circle, and you end up at 0 again, or 2 pi, and then you have another theta to add to that. So this is theta, and you have 2 pi plus theta. So basically theta and 2 pi plus theta end up at the same place, exactly at the same place in your coordinate system. And so basically based on this, you can write that basically, for example, sine theta plus 2 pi is basically equal to sine theta, because they're effectively the same angle. Or you can write cos theta plus 2 pi is equal to cos theta, because again you end up at the same place. Now and because it takes 2 pi radians to end up at the same place in your unit circle, so you say that the period of this function is 2 pi. It means the function goes around this circle, and it takes 2 pi for the function to again start behaving in the same way again, and then you have another 2 pi for the function to behave in the same way, and so on and so forth, and you can basically revolve forever. So that's the period 2 pi. And if you want to show the period here, you can basically do a simple diagram here. And if this is 0 and this is, let's say, pi by 2, if this is 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. So you can go to here pi by 2, then pi, then you have 3 pi by 2, and you have 2 pi. And again, after 2 pi you have pi by 2 again. Let me do this in another color. So this is again pi by 2. This is pi. This is 3 pi by 2. And this is again 2 pi. And this keeps on going forever. And if, let's say, this is 1, if this is 1, and this is basically minus 1, so, and this, if this is basically f of x is equal to sine x or sine theta or whatever, then at 0 your sine is 0. At pi by 2 your sine is 1. So you get something like this. At pi your sine is what is sine pi? Is 0. At 3 pi by 2 your sine is I guess let me see, I don't remember that. What is sine? What is sine 3 pi by 2? Sine 3 pi by 2, here you have x is 0. So again you get 0. No, we made a mistake. So at 0, sine 0 is basically let's see. I don't want to make any mistakes. So sine theta. Any of these tables would do. So sine 0 is 0. Angle sine 0. Trigonometric table. So just let's do a simple table and find out all the values for sine from 0 to 2 pi. So this is theta and this is sine theta, let's say. Sine theta, and if sine is 0, we can calculate it. Basically, when sine is equal to 0, your x value is 1. Let's say your x is 1 and your r value is 1. So 1 divided by 1 is 1. Right? So when sine is equal to pi by 2, what do you get here? When sine is equal to pi by 2, your x is 0 and your r is 1. So I'm sorry, I made a mistake. Here your y value is 0. I made a mistake. So let's just do it again. Basically, sine theta is equal to y divided by r. You already know that. For example, if you have this theta here and this was the angle, so this would be the y value, and then this y value divided by the r value would be the sine of this angle theta. So when you're at 0, your y is basically 0, so sine 0 is 0. When you're at pi by 2, your y value is 1, your r value is also 1, so you get a 1. When you're at pi, your y value is 0, so you get a 0. When you're at 3 pi by 2, your y value is minus 1 and your r value is 1, so you get a minus 1. and when you're at 2 pi, you basically get the same value as 0, so you get a 0. So now you can basically plot these points. So at 0 you're at 0, you're at pi by 2 you're at 1, at pi you're at 0, at 3 pi by 2 you're at -1, over here at 2 pi you're at 0. So this is your sine function. It's not very neat, but well, let me choose another color. This would be your function. And then again, the same thing happens here. Again, at 2 pi or at 0, you're at 0. At pi by 2, you're at 1. So again, you end up here. At pi, you're at 0. At 3 pi by 2, you're at -1. At 2 pi, again, you're at 0. So you can see that this function is basically behaving in the same way in having a period of 2 pi. You can see that starting from 0 here, the function is going upwards. So going upwards, coming down, and going up, and when you get to the point 2 pi, when you get to this point here, again the function is at 0 and going upwards. When you get here, the function is at 0, but it's going downward, so it's not behaving in the same way as it is at point 0. So this is basically one period of the function. It means starting at 0 and again ending up and at the same place, again behaving in the same way. So basically this is the period of your function, which is basically 2 pi. So period 2 pi. Now, this was the sine function. Now cos function basically behaves in the same way, except it kind of starts from here when you have cos 0 is 1, so the function kind of starts from here and starts coming down like this. Let me show you the graph of the cos function. So if let me make this a little smaller so that you can see it. So if you had y is equal to cos x, you can see that for the function y is equal to cos x, the function at theta is equal to 0, you have the value 1, and then you come down here at pi by 2 you're at 0, and at pi you're at -1, and so on and so forth. At 3 pi by 2 you're at 0. At 2 pi you're again at value 1. The function is again decreasing. You see that at 0 the function is decreasing. At 2 pi the function is again decreasing. So this has also the same period 2 pi as the sine function. So that's basically what's meant by the period. So that's it for the period of the functions.